Hello, welcome to lesson 3B-6, average rate of change. Specifically, we are going to be looking at the rate of change for quadratic functions since that's what the rest of Unit 3 has been focused on. Our learning target is that I can find and interpret the rate of change of a quadratic function. So when we look at our notes, we're going to be given that the average rate of change, of a function is the slope of a graph over a given interval. Now we are used to seeing it written in this type of format, y2 minus y1 over x2 minus x1. But another way that you might occasionally see this is with a triangle y over triangle x. And what that triangle means is it's actually a symbol called delta, as you'll see in your little box of notes to the side there. And what that triangle or delta means is that it means a change in. So what this is really saying is the change in y over the change in x, which is exactly what our formula is showing over here. When we do y2 minus y1, that's a change in y, and x2 minus x1, that's a change in x. Now, in Unit 2, we were looking at the rate of change for linear functions. Remember, a linear function was something that went in a straight line that looked something like this. And in a linear function, our rate of change, we were always going up and over the same amount. It didn't change from point to point. However, when you look at a quadratic function, which is going to look something along the lines of this, we can see that we're not going up the same every time, and sometimes we aren't even going the same direction. Sometimes we switch from going up to down. So because of this, when we are looking at quadratic functions and we're looking at rates of change, we're going to have to be given a specific interval that we're going to be looking at that tells us to look at just a small portion of the graph. For example, they might tell us find the rate of change from here to here. And even within that, you can see that the rate of change is not going to be the same the whole way through. So that's why this lesson, we're calling this the average rate of change. It's going to be the average change over the course of that interval. So let's go ahead and jump into some examples. One time you might be asked to find the rate of changes from a graph. So we are asked to determine the average rate of change over the interval from 0 to 2. So this is actually not an ordered pair. A lot of times people want to go ahead and think that this is one of the ordered pairs that we're using. What this actually is an interval that's saying from x equals 0 to x equals 2, what is our rate of change? So what we are going to have to do to find the y values is to look at where the graph is at these two x values and write two ordered pairs that go with that. So my first ordered pair is going to start where x is 0. My second ordered pair is going to start where x is 2. So I'm going to go to my graph where x is 0, and I'm going to go on my graph until I hit the line that we're looking for the rate of change of. In this case, I'm going to see that that ordered pair, when x is 0, would be 0, negative 3. And I'm going to do the same thing with my second ordered pair. I'm trying to make that a little bit neater of a 3 for you guys. Let's see. There we go. So now, I go over to my graph where x is 2, and I go up until I hit my line again. And in this case, it's going to be at the ordered pair 2, 1. So at this point, we can plug it into our slope formula. Just a reminder, the slope formula is on your formula sheet that you'll get on your milestone. But our formula for slope, or average rate of change, is y2 minus y1 over x2 minus x1. And remember, we can label either ones as our x1 and y1 and either one as our x2, y2, as long as we're consistent. I'm going to go ahead and say that this is x1 and y1, and this is x2 and y2, and so now we plug this into our formula. So we're going to have 1 minus a negative 3. Be careful when you're plugging in negatives that you don't assume that the one in the formula is going to cover the one that you're plugging in as well. And then we're going to do 2 minus 0. So a negative and a negative is going to give us a positive. So this is 1 plus 3, which is equal to 4, and 2 minus 0, which is 2. So now we reduce this, and we're going to find that we're going to have an average rate of change of 2. Alright, so now let's look at another example you might see. Sometimes they might give you the function and ask you to find the rate of change over a specific interval. So in this one, we are going to have to plug in these x values, similar to like we did in the graph, but this time we're going to have to actually plug these into the functions. So I'm going to have to evaluate two functions. I'm going to have to evaluate f of 1, and I'm going to have to evaluate f of 2, because those are the two x values that they gave me to evaluate. So I'm going to plug a 1 in anywhere I see an x. So that's going to be 1 squared plus 2 times 1. So f of 1 is going to equal 1 squared is 1 plus 2 times 1 is 2. So f of 1 equals 3. So that's going to give me the ordered pair 1, 3. And then I'm going to do the same thing with 2. I'm going to plug 2 in, which is going to give me a 2 squared plus 2 times x, which in this case x was 2. So f of 2 is going to be equal to 4 plus 4. So f of 2 is going to give me 8, which means the ordered pair I plugged in for x, I plugged in 2, and I got 8, so that's going to give me my ordered pair here. So now I'm going to plug into the formula. I'm going to get 8 minus 3 over 2 minus 1. 8 minus 3 is going to give me 5. And 2 minus 1 is going to give me 1, which gives me an average rate of change of 5. Alright, we have one last example to look at. And this is when we are given the values in the table. So we want to look at the average rate of change from x equals 6 to x equals 2. So again, just like my other ones, I'm going to go ahead and know my x value that I'm looking at. So I know I'm going to look at x values of 6 and 2. And then I have to go to the table to figure out what those values are. So if I look at where x is 6, that's going to give me 35 for my y value. And where x is 2, I'm going to have 3 for my value. Alright, so I plug into my slope formula. 3 minus 35 over 2 minus 6. 3 minus 35 is going to give me a negative 32. And 2 minus 6 is going to give me a negative 4. And a negative 32 divided by a negative 4 is going to reduce to a positive 8. Alright, there is no application video for lesson 2B-6. Make sure you complete your practice and begin to prepare for your mastery check. Good luck and let us know what we can do to help. See you guys next time.